Hello everyone, welcome to ChemUp Academy, where chemistry is simplified and success is amplified. So in today's lecture, we shall be talking about the conductance unit. So this is going to be your last lecture for conductance. Congratulations, we have completed our unit for our prelims. So you can write unit conductance. And lecture number is, I guess, 5. So you can just check the lecture number. I am a bit confused regarding that. And in today's class, we shall be talking about conductometry titrations. This shall be the topic for today's lecture. That means the conductometry titrations. So what are titrations? Just getting in brief, because this is the whole topic of analytical chemistry that you shall be studying for, of course, prelims also, and for mains in detail, of course. Okay. Conductometry is, we all know, that finding the amount of analyte whenever we are given certain sort of volume, and with change in concentration we can find certain sort of things. So this is the basic formula that we perform in our labs, where we can calculate or we can find out the unknown concentration. So this is our burette, this is your burette, and in the burette we take our titrant. This titrant is something whose volume is known to us. Volume is known. Like this, the things work. And in this, we have titrant, or I would say analyte. And in this thing, we are not aware of the volume. Also, one more thing, what we take along with this is indicator. We take what? We take indicator. So performing titrations could be of various types, like acid-base titrations are there, complexometry, conductometry titrations, and of course your redox type of titrations. So we have so many titrations that we can follow, or that we can get to enhance. So this is just a brief of titrations. You all have performed this sort of topic or this practical in your chemistry classes since I guess from 12th class you have been performing this technique, and up till your masters you will keep on performing up till your PhD as well. I would say you will have to perform this. So there's nothing in it to explain it. It is the burette in which you are taking your titrant whose volume is known to us, and using this volume of titrant we shall be analyzing the formation of the with the help of, I would say, the indicator. There shall be change in color by with which we can get to know the endpoint, and after the completion of the endpoint we would jot down the values, and then we can use the instant formula, that is N1 V1 and N2 V2, and hence we can calculate the unknown concentration. That in terms of molarity also you can calculate, in terms of normality also. Usually we follow the normality in the laboratory classes, therefore it works like that. So this was just a simple discussion about the titration. This we all are aware of. Now coming on to the actual topic. Titrations over here could be of various types, as I will mention, like they could be redox, they could be complexometric, or they can be your acid base. And the one that we shall be discussing over here in the unit of conductance is conductometric titrations. So when we consider about the conductometry titrations, so placing on the heading conductometry titrations, how can we titration समझ में आ गया. लाइक कंडक्टेंस का क्या काम होता है? कंडक्टेंस का मतलब होता है कि कितने कंसंट्रेशन में चेंजेस आ रहा है, कि हमारी उसकी कंडक्टेंस चेंज हो रही है. वी ऑल आर अवेयर, जो हमारा कंडक्शन होता है, कंडक्शन बेसिकली डिपेंड्स ऑन द मोबिलिटी ऑफ आयंस. it depends on the nature of ions, and it depends on the temperature, of course. Another thing that it depends is number of ions. This number of ions holds great importance because we would get to know कि concentration तक कैसे पहुंचे, और concentration तक हमें कौन पहुंचाएगा, ये titrations. The titrations that we can perform are known as conductometry titrations. कितना concentration के अंदर changes आ रहा है, due to which conductance में कितना change आ रहा है, उसी को बोलेंगे titrations, conductometry titrations. मतलब concentration के changes के हिसाब से हम अपने कंडक्टेंस के अंदर चेंजेस देखेंगे, ड्यू टू विच वी कैन कॉल इट एज कंडक्टोमेट्री टाइट्रेशंस. सो दिस इज हाउ इट इज रिलेटेड. नाउ titrations could be of various type, like you can use weak acid, you can use strong acid. It is between acid or base. Also, most of the time that we study about this is that we take base in this, and base mostly used is NaOH, and in this we take acid of unknown concentration. ठीक है, so acid could be your weak acid. In case of weak acid it is acetic, and in case of strong acid it is your HCl. So like this the things works. So coming on to our topic, that means the conductometry titrations. And for conductometry titrations we need to get the idea of number of ions, and due to which we can get the concentration from the titration itself, and then we can reach back to this conductometry, or we can say conductance. Now what type of conductometry titrations could be like? We shall be studying the 4 cases. What all are the 4 cases that involves? It involves the strong acid and strong base. This is gonna be your case 1. Then we have weak acid, strong base. Another case shall be weak acid, weak base. And the 4th case that we can consider is mixture of strong acid plus weak acid, strong base. These are the 4 cases that we shall be talking about in the conductometry titrations. So coming on to our first case, that means this case, strong acid versus strong base. Strong acid, strong base means in the burette you shall be taking NaOH, that is the strong base, and here shall be your readings. And in the conical flask you shall be having your HCl along with the indicator. This is how the representation looks like. Now what type of graph we are obtaining from this? The graph that we can obtain is graph is going like this, and then it goes like this. How can I make this graph like this? Is I have taken from the book and then I have pasted? No. The thing is actually here on the x-axis I would mention it as volume of base, and here shall be my concentration. On the y-axis I am taking concentration, and on the x-axis I am taking the volume of the base. Now what is happening? It is saying that say a strong acid and strong base, the case becomes like NaOH we are taking along with HCl. So in the conical flask, we only have HCl, which completely dissociates as H positive and Cl negative. So in the starting of the practical or the assignment, what we have over here is that in the starting of the experiment, we have this as a point we are getting. The concentration of NaOH is completely zero. Why? Because in the starting we only have the H positive ion, only the H positive ions are there. Therefore Vmax is zero in the beginning. That's why I've made a point over here. On marking the point over here, I'll move to the next step. That means I would be adding NaOH from the burette into this flask. On adding NaOH in the HCl, the number of H positive ion goes on decreasing because of the neutralization with NaOH. NaOH is being added to the HCl. H ions were there, Vmax was 0 when NaOH was not present. Now we are adding NaOH, due to which the neutralization occurs and H ion decreases. Due to decrease in this particular thing, that means the number of ions, our conductance usually decreases. There is decrease in conductance as well. Therefore, we can see this line of conductance decreases. Hence, we can say that this is observed. Now we have reached at equilibrium. This is point of equilibrium. Once we have reached this point of equilibrium, we can say that this shall be our Vmax. This point shall be our Vmax, where H ions and this OH ions have completely diminished, means no H ion is present. Therefore, we can say that this point is equilibrium where no H ions are present. Now, why I am saying is that this point is increasing. Why is this line increasing like this? Because after that also I keep on adding NaOH. H has now completely been removed from this solution. Now we are left with OH ions. Due to the presence of the OH ions, I can say that conductance is increasing. Therefore, this graph has been made which represents the OH ions and increase in conductance. OH increases, therefore conductance increases. Here H ions decreases, conductance decreases. And this is the point of equilibrium that we have attained. Again the same thing, strong acid we have, strong base we have. Shuruat mein there was nothing but HCl in the solution of ours. Therefore we are getting this point as Vmax in the starting or in the beginning of the experiment to be 0. This is the point of origin that we are taking 0. Then the next thing is we have started to add on NaOH. There will be the neutralization reaction that will be followed. That means H ions will continue to go on decreasing. Due to decrease in H positive ions, there shall be decrease in conductance. Now we have reached to the point where no H ion is present. That means we have reached a state of equilibrium. Now we are still adding NaOH. Due to addition of NaOH, there is increase in amount of OH ions. Number of ions increases, due to which we can say that the conductivity also increases. Hence, certain sort of graph, whenever you will obtain certain sort of graph, this graph shall represent your strong acid versus strong base. Now, this is your case number 1, which is most of the times asked in your examination directly. They can give you the graphs, they can ask you the pairing, or they can give you the pair like HCl, NaOH. Rest of the pairs could be like NH4OH along with, or they can give you certain options would be given to you and you would be asked which option is correct regarding this particular thing graph. So you need to decide upon yourself, and this you can decide once you have studied what graph actually looks like. So these are not the points to be considered. This is where the graph actually lies. So this was our first case. First case we have covered. Coming on to the second case, that means the weak acid and the strong base. Second point, weak acid and strong base. Weak acid could be your acetic acid and strong base is your NaOH. Weak acid says that we have this and there is not complete dissociation, therefore we can say that CH3COONa, and here whatever is left, that means H ions would be left. Now we can see that this is a weak acid, this is weak acid, therefore incomplete dissociation occurs, and on compilation with NaOH, we have it as a bit strong component. We have comparatively we have strong thing. Now it should be observed that it is weak, it is strong, तो थोड़ा conductance में increase होना जरूरी है. But are we actually obtaining certain things like this? No. Here it is weak, here it is strong, but still we are not obtaining the graph like this. The obtainment of graph, wait. Here it is conductance. We are plotting again conductance, na? So concentration could be calculated directly. Okay. So what sort of graph can we make like this? We can make like, and here we have this. This is how we shall observe. Like we can say this is our Vmax, where this is volume of base, and here is your conductance. This is how it is going. We can say that it should increase. The graph obtained should be like this. Why are we obtaining this decrease? Why is there a decrease in the graph itself? So the decrease could be explained because this CH3OOH is weak acid, and here we have NaOH. We are adding NaOH, that means the base, to weak acid. Therefore, the neutralization reaction will occur. Once the neutralization is completed, we can move on forward. Neutralization में जितना time लग रहा है, that is leading to the decrease in the curve. This decrease is due to what? Neutralization reaction. Now, once we have reached the equilibrium point, then we can see the increase in the graph. Increase in the graph is because of the OH ions that has been released from the NaOH curve. So we do not obtain graph like this, but a graph like this is obtained. This is at equilibrium point. Let's see it again. In the burette, we are having weak acid. Sorry, in the conical flask, we are having weak acid, and in the burette, we are having NaOH. Weak acid को neutralize करने के लिए NaOH we are adding. Now, due to that neutralization, जितना conductance produce हो रहा था, because of this particular thing, जितना भी conductance हो रहा था, okay. Because of these ions only, जितना भी conductance हो रहा था, तो हम कह सकते थे कि equilibrium should shift in the backward direction, it should shift in the forward direction. It was expected for equilibrium to shift in forward direction. पर ऐसा नहीं हुआ. Instead, equilibrium shifts in backward direction. This is correct and this is whole wrong. तो क्या हुआ? पहले CH3COOH था, उसको न्यूट्रलाइज कराया गया NaOH से. हमें लगा NaOH थोड़ा सा स्ट्रॉन्ग है. Since it is strong, therefore graph like this should be obtained. पर जो एक्चुअल ग्राफ था प्लॉटिंग के बाद जो मिला वो ऐसा था. तो कंक्लूजन क्या निकला? कंक्लूजन निकला जो ये हमें डिक्रीज देखने के लिए मिल रहा है, the decrease that we are able to observe in the graph is because of the neutralization reaction. पहले acetic acid को neutralize किया गया with the presence of NaOH. Therefore, we are observing the decrease क्योंकि यहाँ पे सारे H ions खत्म हो गए. H ions का decrease हुआ, number of ions में decrease हुआ. Therefore, हमारा जो कंडक्टेंस था उसके अंदर भी डिक्रीज हुआ. आफ्टर दैट वी हैव रीच्ड द इक्विलिब्रियम पॉइंट. ऑन रीचिंग द इक्विलिब्रियम पॉइंट वी कैन सी देयर इज एन अटेनमेंट इन द ग्राफ. थोड़ा ग्राफ में इंक्रीज आ रहा है, चेंज आ रहा है. तो यहाँ पर शार्प चेंज नहीं है. एक और बात, हियर द शार्प चेंज इज हियर एंड हियर नो शार्प चेंज इज ऑब्जर्व. तो ये बात भी ध्यान रखने वाली है कि हमें कोई शार्प चेंज देखने के लिए नहीं मिल रहा है. वंस we have neutralized our acetic acid, we have NaOH. Because of the presence of NaOH, we have OH negative ions. OH negative ions की number of ions increase होते जा रहे हैं, conductance increase होता जा रहा है, therefore the value of conductance is increasing. और जो हमारा equilibrium था वो शिफ्ट कर रहा था बैकवर्ड डायरेक्शन में इंस्टेड ऑफ द फॉरवर्ड डायरेक्शन. तो फॉरवर्ड डायरेक्शन में नहीं शिफ्ट करेगा, जो हमारा अंदाजा था दैट वाज रॉन्ग. Instead, the graph that we have got after the performance in the laboratory is usually this type of this graph. So, this was our second case. Coming on to the third case of ours, it is quite simple. Third case, अगर explain पर बात आ जाए तो third case कहता था weak acid, weak base. कुछ भी आप ले सकते हो. आपका यहाँ पे कंडक्टेंस आ जाएगा, यहाँ आपका V of base आ जाएगा, and here like this the graph could be attained where your equilibrium point shall be this V max marked as equilibrium, and then after certain point of time it becomes constant as well. Like this the things can work in the weak acid and weak base. वही same चीज, the things have been repeating again and again. That means first neutralization, since it is weak, therefore no sharp point or sharp equilibrium shall be obtained. And now coming on to the fourth point of ours, that means in the fourth point we shall be taking a mixture of strong acid, weak acid versus base. Mixture of strong acid and weak acid versus base. Okay, so इसके लिए पहले ग्राफ ड्रॉ कर लेते हैं. इसका ग्राफ कैसे आएगा? इसका ग्राफ वुड बी लाइक, okay, let me take the pen. Is it clear? Sharp edges बना लेते हैं. Like this the graph shall be attained. I hope these are sharp now. Why is it not coming sharp? Like this it can be sharp now. Okay, far better than before ones. Okay, here again your conductance shall be there. You can mention conductance and you can mention volume of base. अब क्या हो रहा है? Why are we getting two equilibrium points? Why are we getting two V maxes? V max of this, V max 1, and here we have V max 2. See, same thing goes again. पहला neutralization की वजह से we are observing this decrease. This decrease is because of the neutralization, that we can place it like this. Then we got the first point. What is this first point donating? Then we got this first point, that is first equilibrium point we are getting, first V max we are getting. That means this is the equilibrium where neutralized, completely equilibrium हो चुका है किसका? Strong acid का. पहला काम तमाम किया strong acid का base ने, फिर weak acid का काम तमाम किया second round पर काम तमाम हुआ वीक एसिड का. And then this increase is due to base ions that were present due to the extraordinary base that was released. So we are getting two equilibrium points, out of which one is for strong acid. So always remember, Vmax 1 shall always be for strong acid and Vmax 2 shall always be for weak acid. So this is how, if you get a mixture of strong acid and weak acid versus base, so this is how you can solve it. First, there shall be decrease due to the neutralization that is going on in the other processes as well. Then we are getting the first equilibrium point for strong acid. पहले strong acid को खत्म किया, फिर second step पर weak acid को खत्म किया. Therefore, this volume is required for weak acid as well. Then there is increase in conductance because of the number of ions that have been increased due to extra addition of the base that we are getting, due to which the conductance is also increased. So this is how the four graphs could be studied in a very easy and simple manner. And let's just give it a quick revision. Okay, for strong acid we were getting only one equilibrium point. Strong acid tha, so we can take HCl in the conical flask, and in the burette we can take NaOH. पहले डिक्रीज हो रहा था बिकॉज ऑफ द न्यूट्रलाइजेशन रिएक्शन, फिर जब दोनों इक्विवेलेंट पर पहुंच गए देन वी आर गेटिंग द Vmax. आफ्टर दैट एक्स्ट्रा बेस ऐड करने की वजह से जो कंडक्टेंस था वो इंक्रीज हो रहा था बिकॉज ऑफ द बेस आयंस प्रेजेंट. कमिंग ऑन टू द नेक्स्ट वन, वी हैव वीक एसिड वीक बेस, सॉरी वीक एसिड स्ट्रॉन्ग बेस. स्ट्रॉन्ग बेस होने की वजह से वी थॉट कि हमारा जो कंडक्टेंस होगा वो इंक्रीजिंग मिलेगा, बट इंक्रीजिंग की जगह वी हैड थॉट दिस वन, बट मिला क्या, हमारा थोड़ा डिक्रीज मिला. डिक्रीज क्यों था? बिकॉज ऑफ द न्यूट्रलाइजेशन. देन वी अटेन द इक्विलिब्रियम पॉइंट विच इज नॉट क्वाइट शार्प बिकॉज ऑफ द वीक एसिड प्रेजेंस, एंड देन वी आर सीइंग दिस इंक्रीज इन कंडक्टेंस. This increase is due to the presence of the base ions against. Then we have weak acid, weak base, the simplest case ever. Then we have the mixture. Mixture will give us 2 points, two equilibrium points. First will be for strong acid, second will be for the weak acid, and then there would be again increase due to the base ions. That will lead to the increase in conductance. So this was all for today. Thank you and keep watching.
ChemUp Academy. Chemistry simplified. Success amplified.